Hey guys, this is Steven from Steven's Classic Garage, and I'm very interested in doing one of these videos. So I wanted to make, as you know, I'm a graduate, or as you might not know, I'm a graduated mechanical engineer. So I wanted to talk a little bit more about kind of proving these upgrades that I do to my cars on my channel using metrics and sensors and stuff like that. So I wanted to start doing that so I could show like, hey, here's an issue, and here is how you know that it is an issue, because you could use this particular sensor and know that we have an issue because it's acting this sort of way. So what I did for that is I bought this, I wanted to measure some temperature stuff. So I bought this Inkbird IBS TH1, and it's a Bluetooth wireless device, and you could put it up to 50 feet away. And by the way, the wire's way longer than that. And it has this little base that uses a AAA 1.5 volt, which is what AAA is rated for. And it has this really long sensor, which is basically a thermocouple, and it attaches with a regular headphone jack into the back. And so you could use it two different ways. You could either use the disc, that Inkbird disc right there, the IBS TH1. You can either use that separately and plop it down somewhere and read the temperature of something, or you could take it off, or you could use the sensor by plugging in the sensor and then have the Inkbird elsewhere, and then pick up the temperature from a distance where the Inkbird is somewhere else and the sensor is down there. One of the things I do not like about this is that I didn't know this, is that you could only read the temperature of one at one time. So you can't read the disc one and the thermocouple at the same time. And thermocouple calls it the external sensor, and it puts a little parentheses around it. So that's unfortunate. And then obviously the sensor, it does read humidity and temperature, but the sensor, the external sensor only reads temperature. Thermocouples can only read temperature. So, but it's really nice because you could go down to a 10-second sample rate, and it stores the data up to 20 days. But I don't know what setting that's at. So, for example, this is pretty popular. I've heard some guys, they use it for, the one review that I watched, he uses it. He has some very expensive meats, and he has the probe inside something. I don't know if it's some sort of cooker or something, but he has to monitor the humidity and stuff. So I think he has this guy in here. But I don't think it's a cooker then, because this guy, can't get this guy too hot, because then it'll start melting. Here's another one. That would be a good idea for baby or whatever. Anyways, so yeah, this is what it looks like when you grab all of the history, and it will just plot all the history. And then the best thing is that you could export it. So I've done multiple tests. Some I think are better than others. Some I'm going to redo next week. And I plan on doing these sort of tests throughout the week, because it takes like 5 minutes to set up the sensor. And so, and then I basically drive to work, and then I save that, and then I drive home and I save that. Because my trip to work, and this is I could do it on my Rabbbit and also on my Mustang eventually when I get it back on the road after I paint. So I set it up and I drive to work, which the drive to work is about 40 minutes. And that's usually with less traffic than usual. And then driving home, that's when there's a huge amount of traffic, and it's hotter because it's later in the day. I leave usually at like 4 o'clock or 3:30 usually. So that could be anywhere between 50 minutes to an hour, and that's when there's a lot of stop and go traffic, and things start to get hot at that point. So that's kind of the two situations that this usually goes through. There and back. So one at about 9:30, and then one about 3:30 on the way back. And because it has this external probe, I can put it in multiple different places. And I like the external probe because what you could do is you could mount it in such a way that you're not picking up heat through something. So that's where I think my first issue was with this Inkbird. So the first 2 readings that I took were, of course, when I say 2 readings, I'm talking about separate days, because I do the same reading to work and back from work, and then I think of that as a concluded test. So I've done it where because I'm really curious on where this issue is coming from. I have a lot of heat coming through my blower into my car, and I think I showed you guys that on this here when I open this up. So under here is a blower that sucks everything from in through here and goes into the car and then goes out my vents, right? Now, when I got the car, I looked at my neighbor's car, and there's those 2 holes over here. Right here. So, there we go by him. No. Yeah, right there. So there's 2 holes here, and then on my buddy's car up the street, there's actually a rubber boot that goes in there, and it's like kind of like the cross shape. And what happens is when there's no weight from water, because again, water comes in through the grill and comes down this little direction pan and then falls in here and drains out. So there's a little boot there, like the cross, that when there's nothing there, it's closed. And then when there's some weight of water there, it opens up and drains the water out. Now, why that's good is that it keeps heat from going up into here from the engine bay and then getting sucked into the car and spit into my face, basically, from both vents, from both the driver's side and the passenger side vent. So what I did is I did one test where I put the sensor way back in here, right in front of the entrance, and I just put the dial, not the external sensor. So I put it way back here, right in front of the entrance of my, where it comes in, where the air comes in. And then I basically tracked that on the way to work and on the way home. And then I did that for one day. And then the second day, I went in with some double back tape and I sealed this. You can't exactly seal the other one all the way because there's the sprayer hose goes through there. So I sealed that one up the best that I can, and then I basically drove with that like that. And then, so one of the issues is I put it back against this wall right here, because it's actually magnetic. It has a magnetic back, so you can just stick it onto something. So I just stuck it on the back wall over here. But the issue is that this was getting so hot. This was getting hot from the engine bay getting hot. And it was just transferring through the plastic and changing the sensor temperature. So I think it wasn't actually measuring the air. I think it was measuring the material that it was sitting on. So, but that does bring up a good point. So what I'm thinking to keep this area cool is I'm thinking about doing what I did, similar to what I did on the Mustang, where I kind of rust coated this. I was thinking about maybe doing some sort of taking this thing off and then bed linering all of this, so that number one, when water gets in here, it doesn't rot it out. If this ever gets plugged or whatever and it starts to rot away, this won't rot out. And number two, it'll lower the. So there are 3 ways that heat is transferred. There's convection, radiation, and conduction. Conduction is when 2 materials touch each other. For example, my sensor, right? My sensor is touching would be like mounted. It was actually mounted in here underneath this guy. But let's say the sensor's mounted right here. It's conducting through the material into my part. Or for example, this pine needle is sitting right here. The heat is conducting from this piece, which is hot from the engine bay, into this material, into this pine needle, right? Then there is convection, which is basically moving fluid. So conduction is when things are stationary, touching each other, and convection is when something is stationary and the other thing is moving. Actually, both things could be moving. So, for example, a car through air, right? There's convection there. So basically, it's when a fluid is moving over something else. And air is considered a fluid, just like water and stuff like that. Behaves the same way. So that's convection. So basically, as something goes over it, it sucks the heat off or adds heat to it. And that's a coefficient of its density, what type of material it is, what type of fluid it is, what its thermal properties are, its wind speed, its speed that it goes over the body, how rough the body is, the contact area of the body, the how much air is flowing through there, or fluid, the mass flow rate they call it. All those things come into play. And then number 3, which is radiation, just like IR, right? So it's just like when you have those room heaters that are basically they just have a lamp, and you could feel it like really, really far away. That's because it's radiating. So basically, it's sending energy in the form of particles that go to you through the air, and when they hit you, they rub against your skin and they heat up your skin. Right? That's how you could feel something far away. That's how you could feel the sun. It's basically like the sun to the earth. You could feel the sun even though the sun is billions of miles away, right? I don't even know how far away it is. Well, I mean, it changes because we're in an elliptical orbit, but so it's about 92 million miles. Okay, so not a billion miles, but whatever. So yeah, even though we're 92 million miles away from the sun, we can still feel the heat from the sun. That's because it's sending energy in the form of photons, right? Photons or particles or whatever you want to call it. Basically, electrons, elements. They're sending these protons and electrons and neutrons, right, at us, and it's hitting our skin, and we feel the heat from there, even though it's very, very far away. And again, it's going through space, so there's no fluid or anything solid that's contacting it, or very little, basically, very little. So in space is almost complete vacuum. There's nothing, right? There's nothing there. There's no air. There's no solids. There's no nothing. There's no fluids, anything. Or very little, very, very little. It's like 99.99% vacuum. So it travels through there by sending, almost like almost like Bluetooth. It's sending this remote transmission through the air, and it hits your skin and you feel it. So in this case, it's conducting through the wall here. And on the other side, it's convection. The air is getting hot by the engine, the fluid, and the fluid is blowing past this piece and heating this piece up, and then is conducting heat through this piece into our sensor. So I don't want to go over those findings, because basically I want to take the probe now, so attach the thing over here somewhere, or even back over here, so it's not cold. So it's cold, because usually thermocouples, they have some sort of compensation on where the amp is, because basically thermocouples are a combination of two dissimilar metals at a point, and when you heat those two dissimilar metals at one specific temperature, they actually produce two different voltages, but the difference in voltage is very, very small. So what they do so that these microcontroller, basically these electronics can read them, is they have to boost the voltage. But in order to boost the voltage, it needs a point of reference. So it actually has a thermocouple. It actually has a measuring device on that circular disc to compensate for the change in temperature. Because the change in temperature in thermocouples isn't exactly linear, but by using these the compensation, it could get it very, very linear. So I'm going to put it somewhere over here where it's colder on top of this thing, if it'll stick. But this on that other side, on that passenger side, because the inlet's actually on the passenger side. And then stick the probe down towards where the fan is, right where the intake is, and have it hover there, have the sensor hover there and tape the wire down. Because again, the only thing that it is reading is this metal canister right here. So if I have the sensor hang down in there, I'll get a good reading where it's not conducting or anything, and then I'm getting the true air temperature. But what I did learn from that sensor is that it is indeed getting super hot in here. I might even show you guys, I'll show you guys that data anyways. So, but my more interesting data is I decided yesterday to put the external guy up over here, put this guy up over here on the passenger side, and then I decided to have it go right here. So it comes down through that hole, comes over this brace, and then I actually taped it inside the intake tube that goes into the engine right here. So it was taped right here on the edge, on the inside, using Kapton tape, which is high temperature tape. The adhesive doesn't go as high as the actual plastic will withstand, but really, really good tape. So I taped it in here where it's flat against the back. So it's basically flat here. Now, because this is plastic and not metal, I can do that by taping it flat, because plastic is not as good of a conductor as metal, so it doesn't distribute as much heat, and also it's pretty far away from everything else, right? So here's another form of heat which I also want to talk about. So I think I talked about it in this video, but basically I want to isolate the inside of this, but we'll talk about that at a later time. So here's a form of conduction here. It conducts through the plastic and through here. But again, like I said, plastic is a very bad conductor, so the very little heat gets up here. So basically the heat has to travel. And as the heat travels, less of it gets over here, right? So over here is actually cold to the touch, right? And so I stick the sensor in there, and the air that rips through this opening here actually gets inside there, and we could read it with the sensor. So I was able to see that that inside there is actually at 54 miles an hour, because I also bought this anemometer, which is basically, it measures wind speed by using this known opening, and then known pitch of the propeller and all that stuff, and then outside temperature. So it'll determine density of air with probably using 1 atmosphere, which is sea level, and then it could use that to determine the miles per hour that spins through here. I think it goes up to 67 miles an hour, 30 meters per second. I think it's 60 miles an hour. And so I put, and funny enough, this circle is actually the perfect size as this inlet right here. So I plugged it in right there, and it's going like 54 miles an hour at idle. So 54 plus mile an hour of air is ripping past this sensor. So we're definitely going to need that high sample rate. So I did a drive up to work and back with that sensor in here plugged inside the intake, and the main thing I'm looking at is at later in the day going home. And then I also when I send it to myself using email, when I export it from the software and I save it to myself as an email, I make sure that I record what the ambient temperature was at that time. So here's actually the plot. So again, this is every 10 seconds. And here you can see it's measuring the humidity of this dial, right? It's measuring the humidity of this dial, but the dial is not in the same spot as the air is coming in. So just kind of disregard the humidity. I mean, but it's close to the same spot, so I guess you could think of that. And you can see as it gets later on in the day, it kind of goes up. And again, the humidity, I think, on this sensor is not that great, but it's got a good precision. I think it's so plus or minus 2% relative humidity. And this sensor, so up to 140 Fahrenheit, the inner sensor, and up to 212 Fahrenheit external probe. And temperature accuracy, external sensors plus or minus 1 degree Celsius. So that should be perfect for what we need to do. So this is all in Fahrenheit. So basically I took all these samples, which again is every 10 seconds, and I think there's like 300. So here, this is line number 2, and this is line number 252. So basically 200 data points. Now, because this is actually, I drove home from a friend's house, and that's where this is recorded from, so it's not exactly as long. And then this was actually 7 o'clock, about 6:30, and it was 70 degrees Fahrenheit. Was about the average temperature outside during the drive. So if we look here, this is from when it was sitting, and then sitting in front of my friend's house, and then I started to drive, and you can see it drop down to about 77, and then back up. Every time that I get stuck and stop moving, it jumps up extremely high. So what that is it's sucking hot air from around the engine here, and it's sucking in and it's intaking it into the engine. Now, one of the main parts that is most important about engine working is that you want high density air. And now, using a very basic formula, which a lot of students will know even from high school. Actually, yeah, should be like if you went to high school chemistry, is PV equals nRT, which is basically pressure times volume equals nert. N is number of molecules. R is a specific constant for that gas, and then and RT. So T is temperature, right? So if you convert molecules, if you look at molecules over volume, you can figure out density, right? And so pressure equals density times R times T, right? So basically, as temperature increases, so pressure is the same because it's just atmospheric pressure. So as temperature increases, let's say you move it on to the other side, the pressure stays the same, that must mean that density has to decrease, right? So basically the molecules spread out, and you have to suck in more air to burn the same amount of fuel. So what you want to do is you want to make sure that this air is intaked at the lowest possible temperature. That way you could have denser air and you could burn more fuel, especially on diesel. You could burn more fuel before you get smoke, before you get black smoke, right? Without any sort of forced induction such as a turbo. That's the same reason why when you have a turbocharged car, they want you to add an intercooler, because basically what happens is as it goes through the turbo, as you compress air using that same equation, PV equals nRT, as you compress air, as you increase the pressure and decrease the volume, temperature has to go up, right? So now your air is losing density. So what they do is they feed it back through an intercooler, which is just like a car radiator, and it takes some of the heat away through convection, as we talked about, drops the temperature of the air, and then intakes it into the motor. So it tries to drop the air down to as close to outside temperature as possible before it intakes it into the motor. So basically having it like this is a really bad deal, because now I'm basically getting less dense air and it's harder to burn. It can't burn as much fuel at this point. And so I'm losing max power. And so if I try to get on it too much, going up a hill or whatever, it's going to smoke, and I'm basically just wasting fuel without getting any extra power. So again, the ambient temperature is down over here somewhere. Well, here this is a difference of 25, so it's down like here, right? So here I'm at 81, so I'm already 11 degrees. And as I start to get, so here's where I'm driving pretty consistently fast at the lower end. Then here I stop. And you can see here I'm stopping longer and longer. So this is at the point where I get on the freeway on 280, and it's stop and go traffic. At one point I'm stopped. I think this is when I stopped going on to Capitol Expressway to go to my place, and it was super backed up, and I was stopped for a long time. You can see it basically bumps up, heating this sensor up to 121 degrees Fahrenheit. And again, this is with air. This is probably at idle. So this is with air whizzing by at 55 miles an hour. So it's almost as if you're driving fast. So it should be. So basically, what that means is it's sucking in a lot of hot air. That engine bay is just filled with hot air, and it's sucking that hot air inside the engine and basically burning, and then trying to burn as much fuel as it can with that density of air. Now it's basically a linear ratio. So because everything in Pivner is linear, right? P times V, that's linear, equals nRT, which is N times R times T, which is also linear. So if you cut the temperature in half, you increase density by 2. If everything else stays the same, if pressure stays the same and the number of molecules stays the same. So if we half the temperature, then we'll double the density. And theoretically, that means that you could double the amount of fuel that you could pump in there, right? So let's say that if we dropped, so what if we dropped this 121? But again, this is at idle, so you're not trying to spit as much fuel in. But let's say even at this high point when I start moving, this low point. Because basically low point's when I start moving and it starts to suck more than 55 mile an hour worth of air in, and also I get more air coming through the grill, right? So let's see. And so basically the engine bay cools down a little bit here for this segment, and it cools down there, and then I could intake that air at a lower temperature. So let's look at what that, so 92, so let's just say 93, so what we're going to look at is 70 divided by 93. So we're looking at 25. Basically, imagine that that's multiplied by -1. Multiplied by -1. Whatever. Anyways, imagine that this is basically positive. So that's 25%. Alright? So 25%. So basically, we could, if we drop this temperature from here to atmosphere, we could pump in 25% more fuel as we are pumping in at that particular RPM speed, and be able to burn it, theoretically speaking, right? If everything else stays the same, if the pressure stays the same, which it should be, it's just atmospheric, but it's sucking in with a vacuum, but it should be theoretically the same. So I'm going to say probably less than that, but theoretically, thinking about it this way, that is the max. You could add another 25% more fuel, right? And get a better burn. And still get, and not get black smoke. And be able to oxidize the fuel. So one of my ideas with this is I want to check to see, because this is aluminum and then this is bolted on the motor, there's a lot of heat that goes up and into this manifold here, and heats this manifold up. And then what happens is the air comes through here, and aluminum is a very good conductor, even in convection. As air rips around it, it's very good at either taking heat away from the air or adding heat to the air. So as air rips through this guy, it comes back through here, and it picks up a whole bunch of heat off of this inside, off of this this intake manifold before it goes into the engine, which is exactly what you don't want to do. So what I do want to do is I want to do some investigation and open this up and see if they put a coating or something on the inside of this intake. So one of my ideas is to coat the inside of this intake so it doesn't pick up all the temperature from the air. It doesn't dump a whole bunch of heat into the air as the air comes back. Because this is like 160 degrees or something when you stick your hand on it. Or when it's running, it's probably even more. I might tape the sensor on there so you can see exactly how hot this gets. And you could think that inside the air is ripping past this guy. This guy is basically the opposite of a intercooler. It's basically inner heater. So no matter what we do to this, one of my ideas was to make cold air intake, which is I'm basically going to open this part of the grill up. This part of the grill up right here. So this is the opening for the radiator, and then for this car they actually have the grill here, but there's actually a backing plate here that's solid, so it won't actually let air through here. So one of my ideas is to open this up with a Dremel, and then make a cold air intake funnel with my printer here, and have that intake into the engine. And also there is a vent right here. Or I most likely, instead of doing that, I'll let this air come in and cool the engine bay, and then I'll intake the air from this tiny little vent down here, and then I'll let this come in and cool the engine bay. But even if we do that, it's not going to help as much, because basically what's happening is that air is coming in and getting to that intake here, and then it's heating up in that intake and causing issues, right? So it's getting in through this hose here and going into the intake, and is causing a lot of issues. So I want to find out next week. I'm going to find out exactly how bad those issues are, because again, our test was right at the inlet of this sensor, right at the inlet of this tube. So what I'll probably do is I'll probably open this up and then put my sensor in there and just run open filter right here, or I might somehow snake it in here, and then I'll run probably without a filter for one day, or I'll put some sort of mesh or something in there. And then I'll dip the sensor down into the hole, try to hang it in there or something, because I don't want to measure the aluminum. I want to measure the air as it goes through. So I'll see if I can get a way to do that. So what I'll do is I'll stop it here, and I'll talk more about this other piece here in another video. So just because we're already at 30 minutes, and I'll record that later on today. And we'll have this probably every weekend talking about this different stuff. Alright, this is Steven from Steven's Classic Garage. Thank you guys so much for watching. Subscribe, and I'll see you guys in my next video. Take it easy. Peace.